Hello students, good morning. In the previous lectures, we have seen the differential equations, the partial differentiation, successive differentiation, total differentiation and the total differentiation of a function. How to calculate the total differentiation of a function. Now, in today's period, we will see how to determine the exact differentiation of a function. For that, let us consider an expression m dx plus n dy, where m and n are two different functions of x and y. These are two different variables, therefore, the function f of x y can be obtained such that the total differential is equals to given expression. Thus, df equals to m dx plus n dy. We can find f of x y if m and n satisfy the specific condition. That is the condition for exact differentiation. That condition is the partial differentiation of m with respect to y is equals to partial differentiation of n with respect to x. If this condition satisfies, then the function is a exact differentiation, otherwise not. Here, if this condition is not satisfied, the function cannot be determined. For example, consider df equals to 4x cube plus 3y dx plus 3x minus 5y cube dy. For solving this equation, we have to compare this equation with the equation number 1. After comparing that equation, we get m equals to 4x cube plus 3y and n equals to 3x minus 5y cube. Now, here these terms, we have to differentiate the terms m equals to 4x cube plus 3y with respect to y, keeping x as a constant, and in the second term, that is n equals to 3x minus 5y cube, keeping y constant. Here if we differentiate these terms, then we get here x is a constant, therefore its derivative is a 0 and 3y its derivative is a 3, and in the second term the 3x is a constant, 3x is not, minus 5y is a constant and its derivative is 0. Therefore, the differentiation of m with respect to y is 3 and differentiation of n with respect to x is also 3. It means that this satisfies the condition of exact differentiation, that is partial differentiation of m with respect to y is equals to partial differentiation of n with respect to x. Thus, this condition for exact differential is satisfied. Hence, df is an exact differential and therefore, function can be determined. Now, consider another one example. In the second example, df equals to x cube minus y cube dx plus x cube plus y cube dy. We have to compare this equation with equation number 1. After comparing this equation to equation number 1, we get m equals to x cube minus y cube and n equals to x cube plus y cube. Now, we have to differentiate this first quantity with respect to y and the second quantity with respect to x. That is the partial differentiation of m with respect to y, and it is in this term the x is a constant term and its derivative is a 0, and the derivative of the second term, that is minus y cube, it is minus 3y square, and the second term, that is n equals to x cube plus y cube. After differentiating this term, we are getting the 3x square as a y is a constant term, and therefore, if we see this equation, Here in this equation, the partial differentiation of m with respect to y is not equals to partial differentiation of n with respect to x, and hence the condition of exact differentiation is not satisfied. Hence, df is not a exact differentiation. Thank you. This much is the enough for the exact differentiation. Now, in the next period, we will see the examples related to exact differentiation.